Hey peeps, it's Anna here from Tutoring, and as always, it's such a pleasure to join you. So today we're going to be answering a grade 8 Natural Sciences Energy and Change question taken from the Herzia Middle School November 2015 exam paper. So let's dive straight in. Now let's have a look at the narration. It reads, a torch shines on a cardboard box and creates a shadow, and some of the light is reflected. On the diagram above, draw the light rays and label the following: source of light, opaque object, reflected light, solid wall, screen, and shadow. So let's go ahead and start off by labeling the source of light, opaque object, as well as the solid screen. So, of course, the torch is our source of light. The box in the middle is the opaque object, and right here at the end is the solid wall or screen. That's the first part done. Now let's go on to show light rays and what they get up to. So when the torch shines the light onto the box, some of it is reflected because this is an opaque object. Okay, so this ray that is sent back to the direction from where it came indicates or shows the reflected light. Okay, but not all of it is reflected. Some of it passes over the box, as is shown by the arrows here, and creates a shadow on the solid wall or the screen, just like that. All right, so that's done. Let's move on to the next question. Explain how absorption helps us to see different colors of material or objects. How is light reflected, and how does the angle of light traveling to the mirror compare to the angle of the reflected light? Let's start with 2.3. Now it's useful to remember that light is made up of rays traveling at different wavelengths. Okay, so the white light or visible light that we see is made up of these different colors. Okay, our friend Roy G. Biv can help us to remember that the light that makes up white light is actually made up of red, orange, yellow, green, blue, indigo, and violet. And this order also tells us the length of each wavelength. Red has the longest wavelength, and violet has the shortest wavelength in this spectrum. Okay, so that's just a useful thing to remember that will help us also to explain how absorption helps us to see different colors of materials or objects. Okay, second of all, we know that there is a phenomenon known as selective absorption. Now, this is determined by properties of material, and selective absorption is what determines how some frequencies of light are absorbed by a material or object, while others are reflected. It's all dependent on the particular material that is in question. And the color that we see is actually light reflected by the object whose color we observe. What am I saying? For example, a yellow banana absorbs all the other light rays in this spectrum and reflects only the yellow light, making the banana to appear yellow. So if you have a yellow banana, when the light is shining onto the banana, it's going to absorb red, orange, green, blue, indigo, and violet rays and reflect the yellow light rays, making the banana to look yellow. The same thing applies for if, let's say, we're looking at a red apple, for example, it's absorbing all these other wavelengths of light and reflecting the red, which is what we see as a red apple. Now, just for interest's sake, if an object absorbs all the colors in the spectrum and does not reflect any back, that object appears as black. And if an object is reflecting all of the colors or the light in the spectrum, the object appears as white. Okay, just a little extra for later. And how is light reflected? Light is reflected when it bounces off the surface of an opaque object and returns to the direction from which it came. That is how we get light to be reflected. And how does the angle of light traveling to the mirror compare to the angle of the reflected light? Well, we know that the angle of the light traveling to the mirror is equal to the angle of the reflected light. And this is known as the law of reflection of light. Okay, we'll see a little bit more about that in about 3 seconds. Is the next question says solve the mirror maze below. So we've got mirror A, mirror B, I assume, and mirror C, and an incident ray, which gets us started on the maze. Now, when an incident ray falls on mirror A at this angle, it's going to be reflected onto mirror B and again onto mirror C. But let's see how exactly that's going to happen. So there's our first reflected ray. And to determine the angle of reflection, we can draw an imaginary line in the middle called the normal. Knowing the position of your normal will help you to determine the angle of your reflected ray, because like we said just a few moments ago, the angle of incidence is equal to the angle of reflection. All right, so this this reflected ray rather becomes the incident ray that's falling on mirror B, becomes the reflected ray becomes the incident ray because this is going to hit mirror B and be reflected off of mirror C. Okay, again, remember the concept of the normal to help you determine at what angle your light is going to reflect. All right, so that's that for this question. Exciting stuff about visible light and mirrors, reflection, absorption, and all of these wonderful principles. But before I go, I'd just like to say a very big thank you to our epic sponsor for making this video possible. Please read about them in the description provided. Also remember that on our website you can find a whole lot more of these epic tutorial videos. And if you can't find the answer to your question, please send us your question and we will respond with a personalized video just for you. Until the next time, stay epic.